Okay, here's what it says. Exceptional claims require exceptional evidence by somebody called Christopher Hitchens. Truer words never were spoken, and that is exactly what I'm going to present, is exceptional evidence which overcomes any other exceptional claims which are being made by academia, which are claims with no substance. What I'm about to present to you is 100% substantial evidence, material, physical, experimental, undeniable, unimpeachable evidence. I know it sounds like over the top, oh, the guy's making all these crazy claims. Well, good. That's exactly what I'm making, and I want you to respond, and I want you to challenge me. Because what I'm showing is so beyond what is being portrayed now as reality that it's a completely 100% different. So the actual atomic models and all this business that are being claimed today, I'm claiming they do not represent reality. And we have accelerated light, and we have photographed the actual fields that are happen in midair, and I will show you every bit of evidence that actually shows you that physical particle, the charge carrier, what they're calling the Higgs fields, ether particles, polarized particles in the air that surround the charge carrier, which is the light. I'll show light accelerated, and I'll show the particles that come out of them, and I will show that light can actually be divided. I'll show how gravity works, and actually anti-gravity. Anti-gravity can be seen just by looking at a hydrogen bomb go off, or a nuclear bomb go off. Once they expel all their electrons, they go straight up in the air, because they oppose the positive pull of the Earth, because they become positive after crushing all their electrons and then having them bounce away and leaving a positive core. It is expelled from the Earth and goes straight up in the air. Just take a look, you'll see. And the ball at the top of the hydrogen nuclear bomb will start to absorb electrons back to go back into stability. And that's where you see the extreme amount of violence in that ball that is being propelled from Earth. It's very, very obvious. All right, so I'm going to show you some fields, and then we're going to go into this theory. And it's a wild claim. It's way over the top. It's spectacular. I'm not saying anything about that it's not. And I'm saying that it's completely different than what you've been taught. So you have to throw away Einstein and all of that stuff. And I'm talking about electron flood theory. The Earth is being flooded with electrons until it can absorb no more, and that creates the ionosphere. And I will explain every bit of this in extreme, excruciating details. All right, so stay with me, and here comes the fields. All right, my claim is that the fields that you will soon see are created by particles, and the particles come from solar masses and excited matter. Now, the sun becomes extremely excited because of its crushing gravitational pull against all matter, which ends up forcing magnetic interactions in the surface and expelling electrons, and also complete matter with the fully complete. In other words, electrons are just the little bits that are in the orbits around nucleuses. However, also I believe hydrogen and so forth is spit out of here that has a nucleus attached to electrons, and they are seen flipping. Now, when they leave the sun, they are particles. When they enter the vacuum of space, they do not interact with each other because primarily they are 99% negative solar wind particles, which are the electrons. So they stay away from each other at pretty much a certain distance because they will not interact. So in the vacuum of space, there is no nucleuses to bump into by these little electrons. So they are unseen. They're still there. They're still mass. And they're still energetic, waiting to hit something. If they hit the space station out here, it lights up the space station. If they hit a solar panel out here, it forces electrons to cascade through that solar panel. It is obviously an electron, and it is obviously in here traveling towards wherever it is going to interact with and hit. And as it does that, it is expended. That is its nature. It wants to interact with something. When it interacts with another mass, it drives that electron away as light and shakes the whole thing to create heat. In the vacuum of space, there is no complete matter like there is on planets and so forth, and space stations and things like that. So it just comes through here unseen, called dark energy and dark matter. As it interacts, it becomes visible, and it forces other electrons to be driven off in the visible spectrum so we can see them as light, and they also are felt as heat because they will shake the whole structure of the matter that they're colliding with. Literally, mass is a particle that collides. And how does it collide? It collides in a straight line. All right, so if it's going 100 miles an hour, it collides at 1 pound. If it's going 200 miles an hour, it collides at 10 pounds, because there's going to be an exponential increase in the impact as you go faster and faster. Now, what else impacts? There's a spin. All right, these things are spinning. So now, not only do you have the forward momentum, you have the angular momentum, the spin. It's going now. So if it hits it at 1 mile an hour going forward, and it's spinning at 1,000 miles an hour, you're going to have a serious impact. But if it hits it at 1 mile an hour and it's just barely spinning, it's really not going to do anything. So these are the things you have to take into account. What is the energetic potential of that electron? Now, so we know that it's leaving here as a particle. It's in here. It has nothing to collide with. It's still a particle. Still has plenty of energy. If it hits a space station, hits a solar panel, it displays. If it hits here, it is consumed. The Earth has consumed so many electrons that it no longer wants electrons to speak of. They collect in the ionosphere out here. It's still taking electrons because they will force themselves through and smash into the Earth and grow plants and warm up things and do all that kind of stuff. So that's what we're starting with. Now let's go look at the fields that these particles present, because the particles are just particles, little tiny things, zzz, but around them are big round plates of polarized magnetic ether. That's what's called the magnetic field. And once our Earth has filled its quota of electrons and puts itself in the ionosphere starts to collect out here. It's dense with electrons, and I'm going to show you that too. Pictures of it. John Glenn noticed them, and wait till you hear the stories. Now, those electrons out here, that's our magnetic field. That's our field. The stuff comes through their electrons. They are negative. Our magnetic field is negative. They boing away, and they bounce around. That's how it works. All right, so let's go look into the field. And I claim that is the field as it comes out of the other side of the accelerator. These are the fields. These are the particles. These are the actual ether particles. I claim that these are the Higgs particles and Higgs bosons. I claim that light is a particle. There's a particle in the center coming through. It's a charged particle, creates this field around it. The field is not part of the particle. The field is charged, polarized ether. Obviously, I claim that light can be accelerated. I claim that light can be turned into a plasma. And I claim that you can actually hear that sizzle when that goes through that accelerator and turns into that plasma, because each of these electrons is violating each other's region in space and forcing it to become hot and excited. I'm claiming that these are electron neutrinos that are coming out of here. If that's what they're asking for, is an accelerated particle creating Cherenkov radiation, turning into a shower of electrons. That's what I'm looking at, and you'll be seeing this. All of this stuff will be demonstrated and seen. I have many pictures of light, and I have all of the scientific criteria that says here's what a Higgs boson is, and here's what an electron neutrino is, and I'm claiming that I fulfill every single one of those characteristics absolutely flawlessly. I also claim that this shows how electrons and Cherenkov radiation is produced. Electricity, how electricity flows through wires. It's the same as it flows through air. I understand static and how that static charge is attached to moisture in the air and it collects on you. It's a free electron. It's the ether. I understand lightning, how that flows through the air, again with the ether. The particles flowing from the sun are particles, and they are energy, and then when they collide with something which does not exist in the vacuum of space, they become light and heat. But in the vacuum of space, they stay away from each other. They're electrons, which are negative particles. They travel through the ether of space and stay away from each other. We don't see them. They're dark energy and dark matter in that ether. I can tell you why a nuclear explosion goes straight up in the air. You watch it. It doesn't go out in circles. It goes straight up in the air. And you watch what's at the top of the head of the cloud in the air. I can explain that. I can explain gravity. I know exactly how gravity works now. The Earth is a positive, extreme positive mass in its center with an extreme amount of negatives flooding into it, which creates a completely saturated Earth with negatives saturating and flooding the positives, creating an outside shell of electrons trying to penetrate. We call that the ionosphere. All right, I understand the electron flood theory, and it changes the whole idea of neutrons. All right, so all that's got to be talked about. Einstein's theory of E equals mc squared is not correct. Energy is mass, yes. But that's exactly what it is. Energy equals mass. But he said that light has no mass, and that is not correct. Light has mass, and it possesses energy. Because if light had no mass, his own equation would say it has no energy. And light can't be a particle and a wave. It's one or the other, and it happens to be a particle spinning forward in a circle. This I also will demonstrate. So I challenge anyone out there in the scientific, physics, anyone that wants to protest what I present. But you have to watch what I present in its entirety. It's long, and it's involved, but it is very simple for any average mind to understand it because it is reality. You don't have to go 20, 30 pages of nonsense. By the time you're so confused, you just give up. This you will see, and if you don't understand, ask me. I will easily explain it. Alright, so you get the concept of light. It's shaken so violently that those little things that are holding each other in their orbitals get thrown away. Now, this is just representative of how all particles react. They all want to get as close as they can, and they all want to keep each other as far away as they can. If there's a charge in there, it will push it away, and it will also try to attract, because things are positive and negative. So the positive pulls hard, and the negative says, oh, no, 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 you stay just that far away. That's the nature of the Earth. That is gravity. The Earth is a positive, attractive force. However, it sucks in so many electrons that it is flooded. So what does that mean? It means that the Earth itself takes on every electron that it can take on until it becomes negative. So now what does that mean? That means that anything that comes in is held at bay. And what does that mean? It means that there's an atmosphere around the Earth with an ionic crust literally around it. It protects the Earth. Okay, I did a bunch of videos on the light experiments that we did, and this is the most recent one. It's called "Are These Electron Neutrinos?" Now, it starts off with, is this the Higgs boson? Is the Higgs boson composed of neutrinos? And then it goes on to describe what a Higgs boson is. And it comprises two things. It's the boson, which is the particle that spins out, and around it is created a Higgs field. So I went on here, I'm going to show you what I did here. Now, what it requires is an acceleration. Okay, so let's get over here to where it talks about the Cherenkov radiation, which shows this field that gets all mixed up here. It's the Cherenkov radiation. It's an electron shower produced by electron neutrino events, multiple cones, and therefore diffusing in a detector array. So the muon neutrino is different from an electron neutrino, and we are dealing with electrons. And when they step down, it creates the Cherenkov radiation. So then I go on here to display what we found was the Cherenkov radiation, which was that white, and then showing these fields. And you can see the little dots are the polarized particles that form around the charged particle. Okay, so the charged particle is the carrier, and then I go on to do this and show so forth. And then this is Cherenkov radiation showing from a nuclear reactor crashing into the heavy water. And that creates a Cherenkov. Now, what we did was we created Cherenkov by hitting a Venturi, which created a restriction, which the restriction created chaos into each other's regions and forced it to increase in speed. It's no option. What do I got here? Let's see. Oh, this is about Pauli principle. I go on about things here. All right, well, this is a wave that has no... It's not being interrupted by anything. It's just going through the air as a pulsed red laser. These particles out here are exhibiting, because of the way Rod did this in a dark environment, and they polarize particles out here, and they show as the polarized ether. He had some kind of special technique he was using to do this. Now, this is the shot of the acceleration. You just saw that light wave had no visible distortion to it. This one is now becoming sucked into the Venturi, which is here. And there's two round cylinders, and when it hits there, it forces itself in, and it goes spinning out of here like crazy, and it steps down. Well, first of all, it gets very excited, and it creates these reverse magnetic fields all over the place, because that's what happens. A field is generated when there's a potential interaction, there's potential power. When power flies by, it creates a field all the way around it, in a ball. Now, so it's stepping down here, and then it starts making these trails. You see them? All right. Now that's the things they see on the back walls of the slit experiments. Now I did some more out here. We came out now. All right, and this is over the top of the Venturi, looking down. This is the chaotic white, and then it steps down to yellow, then down to the red where it is comfortable. Now, why does it get white like this? These electrons have been crushed into each other's regions. They want to, an electron is just like a magnetic field. You push two little negatives against each other, they're going to fight back. And they will fight back and actually get hot. That's what the nature of heat is when they try to force each other. It creates heat, and it creates light. And then as that steps into the normal unrestricted space, it begins to settle down, and then they start to spin off on their own normal pathways, which they're supposed to. Now, let's see. Okay, this just shows this is what they all see in the light you know, the slit experiments. Because light is really spinning in a like this. It's not coming like this. You know, it's coming like this, and it's a particle. And when it comes through the top, it hits brilliantly here on these lines, and when it comes through the bottom, it hits this side. So if this is this side, it comes over here. If it's coming under the bottom, it comes up over here. That's the way it is. So they spin. Most of them come through the center, but it's quite obvious what it's doing. What do we got next here? And then this here. Now this is what I was showing. Watch this little white particle. Remember, I think I talked about this. These are the little tiny beams, the little charge carriers. These are the particles. And on the heads of them are the fields, the Higgs fields. And that white one, watch that white one. That one there has got some serious power. And it is going to do something that really very strange, and here it is. Let's see if I can go a little more forward.
It's just tight.
All right, well, as a matter of fact, let me just run it through, and I'll say what I was saying here so you can hear it. All right. It's going to bash into one of these, and I'll show you what happens, and it's spectacular. All right, there's the discs. They're coming all together. However, this one comes through. That's the white one I was talking about. You see how it has already, it's got a built-in field that's just tight or something. I don't know how to explain it. I really don't. But I do see what I see, and you can see what I see. We know these particles all came out of here, and we saw a zillion of them, so they're all pretty much the same, except this one. In this particular shot, there's other times it happens too. Now, not often. Now, it obviously has caught up and impacted with this field. It has its own field. It hits this field. When it hit this field, it seems to have created its own field similar to this field. And it starts stepping down, and it shot off a particle similar to this, only tiny. That's what I see. Now you see, and that's what I see, and that's what you see. So my point being is there's a particle in there somewhere, and that particle is influencing the other particles that are around it, and they are forming in a pattern of orbital. Basically, they're almost like, you know, quantum, and every particle is staying away from every other particle because they're interacting with each other, and they're putting them into a stacked up orbital field surrounding that particle and following it out through space. And everything that it comes into interaction with, it will polarize. Now, my point being is, in outer space, I don't think it'll do that, because in outer space, in the vacuum of space, I would love to be able to see if there is a field that is generated around particles. I can see them in space, and I can actually see fields generated around them now that I'm actually thinking about it. And that happened in the tether experiment, and it also happened in the John Glenn. He saw these particles too. So let's look at that. All right, you just saw me show you what I claim to be light particles, and we photographed them, and Rod had a special technique of getting them in the right light, and that is the key. They have to be in the right particular light to show up. Now, and that's what I'm going to display very obviously between this and the tether incidents in 1996. Now, this is John Glenn, the first orbit. Now, the first time anybody went into orbit. Now, he's going through space, and he's hitting a very unusual thing, and then it goes, he can't talk to anyone because he's in the ionosphere where these particles are collect, which I spoke about before, I believe. Now, watch.
They lit up like they're luminescent. I never saw anything like it. They're coming by the capsule. And they look like little stars, a whole shower of them coming by.
Little stars.
They swirl around the capsule and go in front of the window, and they're all brilliantly lighted.
Brilliantly lighted. That's what an electron is. An electron is going to be extremely energetic because it is nothing but energy.
They probably average maybe 7 or 8 feet apart.
They will separate from each other. As I said before, they are ether particles that are nothing but raw energy electrons, and they will stay away from each other. He's saying they average about 7 or 8 feet apart. That is important.
But I can see them all down below me also. Negative.
They just asked him, can he feel anything impact into can you hear a click into the capsule or anything like that? And he's saying no.
Negative. They're very slow. They're not going away from me more than maybe 3 or 4 miles per hour. They're going at the same speed I am, approximately. They're only very slightly under my speed. Over.
You can see some come through fast. Now he's lost communications. He's in this atmosphere.
They do have a different motion though from me, because they swirl around the capsule and then depart back the way that I am looking.
That's because of the direction of the sun.
Are you receiving? Over. There are literally thousands of them. This is Friendship 7. Am I in contact with anyone? Over.
They can't hear him. He's in this static condition. You can hear the sss in the background.
This has been going on since about 1+15. Over. Just after I remarked about the sunset, I looked back up and looked out the window, and all the little swirl of particles was going by. Over.
There's the key right there. Just after I remarked about the sunset.
This is Friendship 7 broadcasting in the blind. Sunrise has come up behind it.
Sunrise has just come up behind me.
In the periscope, it was brilliant in the scope, a brilliant red as it approached the horizon and came up. And just as I looked back up out the window, I had literally thousands of small luminous particles swirling around the capsule and going away from me at maybe 3 to 5 miles per hour. Now that I am out in the bright sun, they seem to have disappeared. It was just as the sun was coming up.
That's the whole key. It's just as the sun is coming up. There's a certain light, and Rod pinpointed it, and he sent me literally dozens and dozens of pictures a day for, I think it was a couple of years. I mean, we went on and on with this stuff, and I analyzed them all. He was looking for actual creatures and things inside the light, and he might have found some. That was the one thing I couldn't really get into with my research because it's nothing I could prove, and I think he got a little turned off on this whole thing because nobody treats anybody nicely when you come out with research, and Rod's research was a little bit over the edge of even mine. Let me put it that way, because he's looking for things that there's no way you can only show him, and he did. He showed him, and I could see things, and I can't dispute him. And when you believe in the things that I believe, there is a light universe, and there's creatures that live in that light universe. So I have a lot of respect for Rod, and I have a tremendous amount of respect for the amount of work he did. You know, he's not a big physicist guy or anything. He was looking for reality. All right, so anyway, let's go on about this. But deep, deep, deep respect from me for Rod, and everybody else should have too, because without that, him doing the things he did and figuring out this Venturi, nothing that I could show, I could prove. But now, what he did shows the things that I'm saying I can prove now. All right, let's go on a little further here.
Only really unusual thing so far beside ASCS trouble were the little particles, luminous particles around the capsule, just thousands of them, right at sunrise over the Pacific. Over. This is Friendship 7. I did not think they were from my control jets. Negative. Over. Roger, Friendship 7. This is Canton. We have TM solid. Go ahead. Over. Roger, this is Friendship 7, and now that sunrise is starting, I have all these little particles coming around the capsule again, just at sunrise.
Just at sunrise.
Roger, friendship 7. I also can see the light on my on steam from the thruster when I operate it. Over. This is friendship 7. I think I can see a little bit of steam spitting against the dark sky here occasionally from my pitched down manual thrust. Over. Roger. This is friendship 7. All these little particles, there are thousands of them, and they're not coming from the capsule. They're something that's already up here. Because they're all over the sky, way out. I can see them as far as I can see in each direction almost. Roger, friendship 7. This is friendship 7. I'm trying to get some pictures of these particles that are outside here. Over. Friendship 7, this is Canton. We also have no indication that your landing bag might be deployed. Over. Roger. Did someone report landing bag could be down? Over. Negative. We had a request to monitor this and to ask you if you heard any flapping when you had high capsule rates. Negative. This was. Over. Well, I think they probably thought these particles I saw might have come from that. But there are thousands of these things, and they go out for, it looks like miles in each direction from me, and they move by here very slowly. I saw them at the same spot on the first orbit. Over. Roger. Are you still seeing the particles around you? Negative. I don't seem to see them around here on this side. I saw a few, just a few, just after I left Canaveral and turned around facing forward. They were coming toward me at that time. I was going, so I know that they are not coming from the capsule at all. I saw the particles in huge quantities at each sunrise so far. Over.
All right, sunrise. Now that was a video by Mars Moon Space TV. John Glenn describes fireflies. Okay, here is some more corroborating evidence from XX Persian X Alien XX UFO NASA unexplained tether overload incident. Well, it's explainable. It's light, but what happened here was NASA put a tether up into the ionosphere. And the ionosphere is where all these particles collect. They are the electrons that are trying to get to Earth. The Earth says, I got enough electrons. Just stay there. When I need some, I'll call for you. Then they get sucked to Earth by the magnetic pull of the positiveness of Earth. So these are negative particles. Now, I can't account for monopoles, but they must be monopoles because they stay away from each other, and they are brilliant packets of energy. I cannot account for it. But like he said, they're stars, fireflies. Now, this tether was stretched way up into the atmosphere, and then it snapped. So they're just looking at it and saying, oh, look at the tether, da 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 da. Well, isn't it beautiful? Well, all of a sudden, the light particles start showing up, and they are at a loss for words. So let's watch this. It doesn't go long. Now, so they're out in outer space here, and they're looking up with the space telescope, and they're looking from the space station. So here we go. Right, that's the tether. At this point, they're not talking for some reason.
This view showing
See, they don't know what all this stuff is. He said,
the satellite. Again, just moving into sunrise.
Just moving into sunrise. Now watch what happens.
81 nautical miles now from Columbia.
About 81 nautical miles from Columbia. Now I imagine, I'm not sure whether that's north or south, I don't know. You see them coming through? These are exactly the same as I'm seeing in the experiments Rod and I did. And they are brilliant little packets of light, always coming into sunlight. They're coming from every direction too, so it's like I said before, this is a cooperative effort of the universe shooting these particles, and they will interact where they can interact. So now they're saying, oh, go try to fix that thing. They're coming back to it. They don't know what to say. They're just...
Getting the image?
They have no clue what to say.
Franklin, we see a long line, a couple of star-like things, and a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated.
Same old bullshit. It's just a debris that flies with us. No explanation whatsoever. Oh, don't worry, let's just adjust the cameras. Not going to fix it.
At the sun at such low angle, so there's a lot of stray light, and it's getting washed out quickly, but Claude is trying to do a quick, good job here adjusting the cameras.
Yeah, you can't adjust this out, pal.
Copy that.
You know, that description by the crew, this is the tether in the satellite. The satellite with approximately 12 miles of tether still attached to it. Columbia and the satellite are now just passing over the west coast of northern Africa. The two...
You see how they have that little cut out of them? I don't know what to think about that. You know, we have photographed the actual, what we think are these same particles. I really don't know what to think about that.
Two spacecraft now 90 nautical miles apart.
They almost all seem to have them. Yeah.
Controllers for the satellite did have communications with it during the close pass between Columbia and the satellite.
Columbia, Houston, that's a much better view, a lot more contrast visible. And how wide does that tether appear to be? It seems to resemble a much wider...
Do you see that? Look at this. It looks just like it just sort of walked itself right around it. Like this does not need any more electrons, so it just sort of walked over it. Let's look at that again. I noticed that before. Very unusual. All right, so, well, let's back it up because I think this is one of those wobblers. All right, let's see how it comes in.
Columbia, Houston, that's a much better view, a lot more contrast visible.
It's not a wobbler.
And how wide does that tether appear to be?
Look at that.
It seems to resemble a much wider strand than we'd expect. Can you describe
but this is the same as one of these wobblers, but it's not wobbling. There's a lot of variation here. See, that one's not wobbling. Same sort of thing, though. Now, this guy's trying to adjust it in. He can't change this because these particles are actually there. And they are the same thing that John Glenn talked about. So they don't pay any attention to reality or history or anything. This is light. These are light particles. They're collecting up there. There's no sense going any further. They're collecting in the ionosphere because the Earth is charged. The Earth is charged full of them. So it says, I'm negative. I got enough. I'm fully loaded. Just stay out there. And they say, no, we want to come in. Now, at some point, they break through. I'm not sure how that exactly works. But it's once they break through and they begin to get accelerated and pulled to Earth, they become light and heat when they bang into the other molecules that are around the Earth at these high speeds because they're being sucked into matter. I can't see any other way this could possibly be. Now, John Glenn was at 162 miles was his average altitude. Now that is dead nuts right in the center of the ionosphere, and the ionosphere is ions are these electrons. They're polar particles. They're charged particles. Now, he was there and observing them in the sunlight. As the sunlight came through at a certain angle, they would display. When the sunlight came, it was probably like on the side or something. I'm not sure of exactly the interplay between the sunlight and the ionosphere, but it obviously was only during sunrise, and then it would wash out. So that's what it is. Now, coming down from here, these electrons are trying to get in, but the Earth itself has absorbed so many electrons, because that's primarily what the sun is putting out, and every other solar mass is putting out electrons. So that means the Earth is flooded with them. It has every bit of it they can take. It doesn't want any more to speak of. But they do come flooding through, and I can't totally explain that, except for the fact that plants eat them, and they need them. So they're sucking them down to Earth. As far as I can determine, it's something along that line. Either that, or there is some way that they're coming down, being sucked to Earth, and somehow rotating back out of Earth at the poles. But I cannot find that mechanism. Although I did find something in antiquity that really stimulated my imagination, and I'll show you that right now. Now pay real close attention here. This is, I don't know where this came from, to be perfectly honest with you, but it's from antiquity somewhere. Now, this obviously is the sun. That's my interpretation. These are the little, like, they're showing them as bells, I'm going to call them, but that's the representation that I see the same. I see them. They come like that. Now, you see this break right here? I'm looking at that and I'm saying to myself, well, what's that all about? It's obviously they follow the same pattern here. This outline here goes to here. Then I see this line coming back up to what I assume was maybe the moon. Then I see this sort of wavelength coming over here to the moon. So what am I'm looking, I'm thinking, what could this be about? Could it be showing me that the moon puts out a lower radiant light, which it does, but that would be to Earth, because it takes light in, the same light that's shooting this way also shoots here. So you would get less of this coming this way, so you get this sort of a slow wave. So I'm thinking that might make sense, but it's going the wrong direction. And why is this going up to here? And maybe they just misaligned something. Then I thought, no, that's impossible, because this particular line shows that it's lined up here. I mean, apparently to me, it's very well lined up. So why is this thing sitting here? And why is it on this line? What the hell's going on? Now, the only thing I can think of is that this line designates the ionosphere. And the ionosphere somehow allows this kind of an interaction, where the moon radiates the light back, I mean, somehow the electrons back very gently. I just can't explain this. But it looks to me, I'm putting the pieces together, and I'm thinking this line is in the right place for what all these things I'm seeing. This is going back to the moon. I can't explain. It looks like lightning to me, or static electricity, the kind of thing you see, a little squirrely line. This looks like a sine wave of a very slow pushing of the electrons back to the sun. And then the sun sends them back in the same particles that we visualize in the experiments that we did. That's all I see. That's what I'm seeing. I don't know if that's true or not, but that's what I'm seeing. And these patterns are all over Earth. I mean, all over Earth are these circles like this. Everywhere in antiquity. I think they knew about neutrinos back then. This is where it all started. This completely did not understand what they were seeing. Light is a particle, and it spins forward in this manner. Alright, so as it spins, you watch that particle. If it comes up to this slit and it hits going this way, it will spin off in that direction. If this particle now is coming this way, it will spin off in this direction. So we get this and we get this. We get this and we get this. That's why we're getting these patterns. It goes this way from underneath. It goes this way from the top. So it's coming here, it's coming here. Now if it hits this way, you're getting just a little one. If it hits in here, you get a little further. If it hits over here, you get a little further. If it hits over here, you get a little further. That's all it is. They think it's something to do with a wave coming this way. Well, there is no wave coming this way of nothing. They think it's a wave called magnetic radiation, which has no anything, which creates nothing. It's just total nonsense what they decided based on this. Ever since then, and that's 1801. They've been just going off of this for 217 years. Look really careful at that patterns, how they're interweaving these things, and then they're coming out into a nice flat pattern. And I'll show you exactly what we're showing in our experiments, only we're showing it because it's spinning in a circle, just like I showed you with that spring. Alright, this is exactly what it is. This is the particle, and this is its trajectory. Now, it's just a particle. It's not this whole thing. It's just a particle. But as it spins, it comes and hits here, and if it spins and it comes through the slot, it will go in this direction. Okay? If it hits it coming from the bottom, it will go in this direction. So you've got here and here. If it comes way over here and it hits, it's going to stay in close. If it comes way over here and it hits, it's going to go further over. That type of thing. All right, so that's why you get these. It's the spin and the hit and the way the Venturi is set up, and you get these different, and that's all because of a particle that's spinning, and it's a right-hand spin, and I can show you that too. All right, the acceleration is here. They're spread apart, the disk. This is the particle. It's drifting to the left. That means it's spinning to the right, which is what the right-hand rule is. Now, as it's leaving the accelerator, it's expanded. It will start to compact. As you can see already, it's compacting. All right, you see it compacts. And it starts slowing down. Each one of these is a particle. So this one here, so it happens to come right straight through the center. So it's extremely, powerful. And one of these are the type that might hit one of those and create that mini disc. And basically, that's one of those excited ones. And then it hits another one of these and creates a mini disc. All right, and there's that excited particle crashing into just a standard particle and stepping down to its own particle and dropping off a piece of a particle. So if this is light, which it is, because it's just coming from a red laser, that's light as far as I'm concerned. These are the particles, or the fields actually, that are impressed around the particle. This is a portion of a field which is a semi-particle to me. There's got to be a particle in here somewhere that's causing this field. And it's much smaller than the other ones. It appears. It might step up. I have no clue. But there's a lot to look at. This is simple. Very, very simple. What is an ion? What is an ion? An ion says it's an atom or molecule with a net electric charge due to the loss or gain of one or more electrons. So it's either a positive ion, which means it's given away an electron, so it wants to grab an electron, or it is an extra electron, which will repel electrons. Now, they say it's an atom or a molecule. I say that's not necessarily true. I agree with that in some cases, but in other cases it's free electrons. That's all it is in the vacuum of space. Not all it is. There's a lot of full particles, and I can see those as well in the tether incident, and I'm going to point those out in a second. But these are ions. This is the important thing. An extra electron, or not an extra electron. I mean, minus an electron. So it's got one extra, or it's missing one, at least. Alright, so based on the fact that an ion is got either a nuclear particle and an electron in the orbit, or in my world, it also can be just the electron. Now, what would exhibit? One would be like a little flippy thing, I would imagine, because it's got a plus and a minus, and it would be maybe spinning around or, wobbling or doing something. The other one would be just a glowy particle, you know, it might be sort of pulsating or something, but it wouldn't be flip-flopping like a bar magnet spinning through space, that type of thing. So let's see if we can identify those things. All right, this is what the sun looks like, and the sun is another mass that has a nucleus in it, and that nucleus is a strong positive attraction, so it keeps its electrons tight as well. But because it's strong, it's pulling them in tight, and they force themselves into each other's regions, which creates a lot of chaos. And then it creates somehow these magnetic flips of particles. Now I can't account for that. There's solar flares and solar sunspots and all these kind of things. But the net effect is that particles are being thrown from the sun. Case closed. These are being thrown out particles. All right. I'm saying that most of them are electrons in my world. And those electrons are negative particles that were in orbits around nucleuses that have been so crammed into each other's regions that they get expelled in these flares. Now, they leave the sun and they stay away from each other because they're negative. They don't interact, so you don't see them, but they are particles and they have energy and they are moving through space trying to interact with complete matter. When they interact with complete matter, they bounce into the orbitals of the electrons that is in that complete matter and give off light that we can see, and the rest turns into heat that warms up that item. That's how the interaction of these negative particles flowing away work. And they collect in the ionosphere because the Earth is so flooded with these electrons, the negatives, it doesn't want anymore. So they collect in the ionosphere, and we're going to look at that right now. All right, what I want you to do is look at this again with a new set of eyes. Now that I know you've seen this before, but now we're going to look at it and start thinking about really what we're seeing. Now watch this glittery effect on here. I believe there's some kind of a coating because this was supposed to pick up light and attract it and send it back down. And of course it exploded because it took much more current than they had expected. Now, watch these particles. Some will come from every different direction. Now, the sun will radiate from a certain direction. We'll get predominantly more from that way. However, they do come from everywhere in the universe. I mean, everything puts them out, and they just keep traveling until they sort of intermingle with these that are in our ionosphere. Now, I'm not sure what the height of this is, but it's in the ionosphere. Now, and it's not way, way up in the ionosphere. So, let's watch the interaction of these particles and try to understand what we're seeing. All right, because I'm saying there's double ones. They're going to do this little flippy thing, and then because they have a nucleus, and then they also have the electron. Then there will be other ones that are just electrons that have achieved escape velocity from their atoms, and he got thrown into space. All right, so let's watch this.
The satellite, again, just moving into sunrise.
So you're just moving into sunrise. Now I'm just going to turn him off so we can watch this and listen. Now, you see they're going this way, they're going that way, they're round. Look, shoom, shoom. Some of them are coming real fast, some of them are coming slower. Now, I believe the bulk of them are coming from this direction, which is probably where our sun is. Now, other ones will come this way, and some of them are brilliant and some of them aren't. And here they are. These are round ones, and they have a little cut in them. And I believe the reason for that is, and I can explain that, we show ours with like a rounded thing like this. Well, it's smashing into atmosphere. These aren't smashing into anything, so they wouldn't have this shock wave like that. They would have that rounded cut effect, almost completely round, with maybe that little cut. That's all I can assume. But in the atmosphere, where you're really bumping into a lot of molecules, it creates that shock wave that I showed in the red pictures before. So now that we're watching more, here we go now. So they're trying to get this out of the picture now. Now you can see more, and they're going to try to adjust it in and out, and it's not going to work for them. But we're going to watch and see, because some of them are going to start flipping. Now, and I think it's got, let me make another point. I think the ones that start flipping are because we're in another, we're starting to come in more to the source of the flippers, wherever that might be. So let's see if we can detect where they might be coming from. I'm doing this with you. I'm still trying to learn with you. I see, that's one is drifting up. That must have come down and bounced back. There's one coming down, flashing, poop, 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 poop. We haven't seen any flippers really yet, so we're waiting to come into that interaction. Somewhere in space we're going to hit a point where we're going to get the flippers have come from somewhere. And they're like that. Look at that one. Look at that. You can see that one there has a tremendous amount of energy, and it looks just like the fields of the ones that I show in the experiments we did. Absolutely just like it. Now, sooner or later the flippers are going to start showing up. They're going to try to, at a certain point they'll wash out. But now, see, now they're backing out, and they're going to try to, they're trying to adjust this out. Now we're seeing, look at that. Now see, that's a flipper. All right, that is absolutely different than the other ones. There's no question it's different. It's a flipper. Now, what does that mean to us? See, there's another one in that same plane. See the plane, up at plane? And that one almost looks like it interacted with the shaft. Here's another one coming from this direction with that plane, another one with that plane, same plane, same plane. There's a source of these flippers, and I would think it might be the sun coming from here or wherever, but they're all facing like spaceships coming this direction. Some of them are spinning faster than other ones. Right? And that one seems to have changed as it comes into the more dense electrons, maybe. I don't know. Or maybe it was because they're trying to drift in and out, because they are trying to get it out of there, but they cannot. And the sun, see, it must be, I don't know which side it's coming from now, but the sunlight is starting to come up, and it will wash these out eventually. All right, I guess that's enough. Okay, this says that there's ether, whatever you want to pronounce it, is the electron clouds. And that's what I've just been talking about. There's a plus and minus. I once thought that all matter was bipolar and there was no monopoles, because I could not account for it. And I will show you what an electron looks like. And I also can't account for that if it's a monopole, because it has a dark and a white region. Now that tells me that there's two. A dark means there's no energy, and a white means it's loaded with energy. And I'll show you that right now, and then we're going to go into a little deeper. Okay, you know that I claim we accelerated light, and this is the light coming out of the accelerator. The accelerator is right here, and it's coming out chaotic and white and radiating the Cherenkov. Now, then it turns into waves, and I'll go further away, but I'm going to show you close up now. And it goes, it sort of starts degrading, and then you get two of these, two waves of these. Now that's black, and that's white, and there's spikes coming off here of the same two different colors. That says to me that there's two different polarities there, or there's two different somethings there. And in my world, white is power, and dark is no power, or no light, or no energy. All right, so there's your two waves. Here's what happens. It comes out of the accelerator, starts to step down, boom, boom, and then starts to go into its regular pattern. And here it's white, white, then it does this, and now it's dark, white, dark. That's all I'm seeing. You're seeing the same thing. And that's what it is. All right, now this one here is, now I think he's using a green laser here. Now, again, Rod did this, so I'm not positive. But it looks to me, and this goes back at least 2 years. And since then, I really haven't had any contact with Rod, unfortunately. So as I recall, this was a green laser, and I can see that it's not two waves. It seems to be a significant more distance from the accelerator, and then you get the two electrons, or whatever you want to call them, particles. That's what I'm seeing. I don't know what else to say. All right, now here's the only thing that I can come up with after long thoughts about this. A torus has a neck in the center, and then it has capacitance areas, and a neck would be what you would call an inductor, a choke coil, because it's a restriction. Let's put it that way. There's a restriction in there that only so much can pass through that core, much less than can pass through the huge areas that are in the torus, that big round, the round area of the torus, how it folds into that neck. And I'll show you a torus. Now, I'm going to try to explain what I think might be happening, but I originally thought this was a bipolar particle, and I still do, because that's what I'm seeing. But I can't account for its I mean, there's a lot. I don't have the answers. I'm telling you right now, I don't have a lot of the answers. I mean, I have a lot of questions. I have some of the answers, I think, and I'm getting closer than most people, but there's still a lot you got to know. Now, and I'm going to show you one more thing that I think might have something. It's called inductive and reactive capacitance. So let's look at what a torus would do if that was a torus, and I don't know why it would be a torus, but it might be. All right, all I can say is a field pulls in onto itself. We know that because you take the Earth and it's a magnetic field pulls into itself at the poles, which creates this vortex. That's what I'm saying. It looks to me like that would be a torus, the Earth using its own magnetic field. So let's say this internal choke, let's say there was a hole right straight through the Earth, and those magnetic fields wound right down into there. Well, they would choke in here, and a choke means that it restricts the flow of the electricity. Now, it wouldn't just keep going like this in the thing I'm talking about. I'm saying in mine, it would come in there and bounce back, and come in and bounce back. And the bouncing back means that a choke coil will react back against the incoming current up to, 10 times at least. It depends upon the coils. Now, so whatever comes in here, here's what happens. Somehow a current, and I cannot tell you the means of it, but it induces a current to flow into there. As it flows in there, it starts to build a field around it. And you saw the fields. They start to build. And as they build, it opposes the current coming in. It says, hey, stay, get back. And it says, no, I want to come. And it says, get back. And finally the guy coming in says, all right, I just can't push hard anymore. And it collapses. When it collapses, that field squishes, just like squishing a tube of toothpaste. And it pushes it back here up to 10 times as much as it was coming in. And I'll tell you, I got to tell you a funny story. I worked in this area, and I did a lot of all kinds of crazy things. So anyway, I had my wife one time. I said, look, I got this solenoid. And a solenoid is nothing more than a coil of wire. And when you feed it with electricity, 12 volts, let's say, that field builds up, and it pulls in a plunger that's made out of steel, or it's some kind of a magnetic material that it pulls it in. When you release the field, it lets it go. So I said to my wife, I said, hold the two wires on the solenoid. And she said, I'm not going to get a shock. I said, don't worry, it's 12 volts. You can't give. I said, look, touch the 12 volts. She touches. She says, oh, okay. So she grabs a hold of the two wires, right? So I pop the 12 volts, and of course the solenoid kicks in. I said, oh boy, it's all fixed. I let off on the thing, and she goes, ah! She starts screaming. I said, what's the matter? She said, I got a shock. And I started to think, holy smokes, she's right. The reverse electromotive force, they call it reverse EMF, is going to be 10 times what was put in. So now, as soon as I let go, she gets whacked with 10 times. And the same happens, you know, in generators and motors and all that stuff. It's a reverse EMF, it's called. Anyway, so what happens? It's coming in here, and it goes, and squeezes it back. It goes in here, and it says, hey, this is no problem. Let's go back this way. And it starts coming and says, no. And it squeezes it, and it pushes it back, and it's doing this flip-flop. Only thing I can see. Capacitive, inductive, or inductive capacitive reactance, depends on which way you want to start. Was the chicken on the left or the right? All right, I talked about the ether. Now, and I showed it in the red laser photograph, which I will show again momentarily. What that ether is it is negative electrons that are attached to water molecules in the air, moisture that's in the air. It's the relative humidity. So there's relative humidity, absolute humidity, and so forth. Now, the absolute humidity is the total mass of water vapor present in a given volume or mass of air. Now, this will be able to prove exactly what I'm saying, because we can show a ton of particles in the air, or we could show just a few particles in the air, depending upon the relative humidity. So it's grams per cubic meter, or whatever it is here. Absolute humidity in the atmosphere ranges from near zero to roughly 30 grams per cubic meter when the air is saturated. Now, Rod took his pictures, I believe he was by the coast in Australia, and I'm sure the humidity was fairly high. It was in the summertime. Well, I mean, went on for quite a while, but I'm sure there was a lot of humidity in there. Now, I'm going to show you the pictures that he took, and I want you to remember something about water molecules. They're a tiny molecule, H2O. There's 2 hydrogens, 1 oxygen. That is a tiny amount of mass. Tiny. All right? So, they can go at just about anywhere, and they float in the air, and they are invisible. It says it in here, somewhere in here, it says it's invisible, and obviously you can't see water vapor in there. So that's what humidity is, and you see what humidity is, the amount of water vapor present in the air. It's in the gaseous state and is invisible to the human eye. All right, so, but electrons collect on it. Now, what happens with the electrons? They will end up sometimes collecting on you because you are more positive, and you attract those negative electrons, and then you become static. You have static charge build up on you, which is just a bunch of these electrons, which is the ether particles. Then when you touch something, zip, they go to ground. That's where they want to be, is in ground in the earth. That's what they mean by in the ground, because that is your positive attractive force. All right, you see this here? I'm saying all of these are actually moisture. They're all moisture molecules, and they become polarized as this charge carrier particle crashes into the atmosphere and sends out shock waves that irradiate and polarize these particles. Now, here's my point. Here, and we can prove if I'm right or wrong. It can be debunked. This, I believe, is in a very moist environment, and that's why they become so apparent. Now, if it was in a drier environment, you may not even hardly see these particles light up because there's nothing literally for them, or there's not a whole lot for them to crash into. Water molecules, when they are dense in the air like this, really create quite a barrier to the light, because they're kind of dense. Water molecules are so tiny that if it's very moist, you have a pretty solid barrier that this light has to break through. And that's what it's doing here. Virtually like a sonic boom in air. It's virtually identical. The light coming through here is the charged particle carrier, and it's creating this. Now I'll show you one that Rod did through glass. And because in air you don't see the like a real tubular effect. You see sort of a wavy effect, but through the glass it's more of an obstruction, which creates a bigger bump actually, and I'll show you that. All right, now I'm almost positive. Like I say, it went back a few years, so I'm pretty sure this was glass. There was some glass, a curved glass or a flat glass. I can't remember what it was. But when he hit the glass, it came through here, and and you could see it's bumped over. So it's trying to force its way through much more mass than is air. That's the way I'm taking it. I could be wrong. Okay, you saw the blue and you saw the red, and you're seeing this. This is a shock wave from something trying to go faster than the medium it's allowed coming through. Now, these wave off this way because of the force that's coming into it. It creates a shock wave, which is not flat. However, in the other acceleration of light, we get a flat wave, which I believe is the Higgs boson, which is the neutrino they've been looking for, which is a flat wave. It's not a shock wave like that. All right, I'm going to leave it at that. My video card is about running out here. So anyway, these are flat plates. And why are they flat instead of that wave that had entered this? Because it entered as a wave. And I'll show you that one more time before I get out of here. It'll be the last thing you're going to see. As it entered here, it was a wave. It comes out as a tiny little ray with a particle disk. The field is, the particle is a ray. The field is created around the ray, around the particle, because it's a charged particle. As it moves through space, it creates that field. And because it's accelerated, it's moving fast, and it creates a strong field. And you can see it's polarized. All right. And if you look at, and let me show you the other thing. All right, don't forget that's just floating through the air from the laser. And if it wasn't going through the Venturi, it would just keep going like that. All right, this forces this to compact and go through this Venturi, creating atomized white Cherenkov radiation, stepping down into rays of particles, which I believe are the boson charged particle carriers. And they head, at the head of each one of them, there's plates which are the polarized magnetic field, which sets up within the ether, which the ether is attached to moisture particles, and that's why we see them linked together like little magnets in a row around in circles. So they display the magnetic field. And there they are coming out of the accelerator. Those are the rays. Those are the plates of the magnetic fields that head the boson particle. These are the Higgs fields, as far as I can determine. Everything they ask for: acceleration, Cherenkov, particle, field. So, my good friends, I think I have displayed what I said I would display, and it all points to the fact that Earth is a positive mass, predominantly, that is flooded with electrons, and all the electrons that are spit out through solar masses and excitation in the universe will try to seek complete mass to attach itself to. And the Earth is a complete mass, and the electrons are drawn to Earth and have so filled the Earth with excess electrons that we are able to use electricity, and they grow plants, and they are forcing themselves in and creating heat and light. And then they also protect us in our magnetic field, because they have built up such a crust around the Earth, trying to penetrate to get to the positiveness. So I believe I have proven my statement that Earth literally sucks. Now, Mud Fossil University is where you can learn much more about everything. It is the final citadel of truth, and we are welcoming you at no charge. Please come up, And look, if it doesn't mean anything to you, it doesn't mean anything. If it has meaning, it has meaning. But it certainly will stimulate thought. All right, thank you for spending this unusual amount of time. And I hope that if you have any questions whatsoever, I am fully willing to try to address them to the best of my ability. All right, thank you. God loves you, and I do too. All right, take care.